Hi everyone. Today we're going to be looking at some exact values and the unit circle and what that looks like. Now in methods, there are some exact values that we expect you to remember. And there's two ways that you can remember this. The first is using the triangles up the top, which I prefer to do because I'm more of a visual person. And then just below there's a table that we're going to fill out as well. So it's up to you how you choose to remember your exact values. Now all your exact values are your ratios, so your usual SOHCAHTOA. So sine being the ratio between the opposite side of the angle and the hypotenuse, cos being the ratio between the adjacent and the hypotenuse, and then tan being the ratio of the opposite to the adjacent. Okay, so feel free to pause here and just have a go by yourself, but I'm going to go through them as well. So for sine pi on 6, once again, up to you how you remember it. I like the triangles personally because I like to draw out the longer side so I can really highlight which one's the 30 degrees and which one's the 60 degrees. All right. In this case, for sine pi on 6, you're going to be looking at the opposite to what's at pi on 6, which is also 30 degrees. The opposite to 30 degrees is going to be 1. And then the adjacent to the 30 degrees is going to be root 3. And the hypotenuse is going to be 2. Okay, so you're really just looking which one's opposite, adjacent, and hypotenuse to the angle that I'm looking at. Okay, sine pi on 4 I always find easier to remember because it's the same as cosine. But the opposite to pi on 4 being 45 degrees is 1. And then our hypotenuse is root 2. Then for sine pi on 3, the opposite to the 60 degrees is root 3, and the hypotenuse is 2. Now, not every triangle has to have the lengths 1, 2, and root 3 if they're 30 degrees and 60 degrees. What that means is that the ratios are always going to be 1 to 2 to root 3. So if I doubled all these, I would still get a similar triangle. Okay, so these still have the same ratio. So it's not always the same length, it's just the ratio to keep in mind. Now for cosine pi on 6, you're going to look at the adjacent. The thing with cosine and sine, because they work opposites, cosine pi on 6 is going to be the same as sine pi on 3. So cosine pi on 6 is root 3 on 2, but if you had a look at the 30-degree angle, you would see that root 3 is the adjacent there. Then for pi on 4, same thing, we've got 1 on root 2, and then cosine pi on 3, the same as sine pi on 6, is going to be 1/2, okay? Then for tan, looking at pi on 6, we're going to be doing the opposite over the adjacent. In this case, the opposite was 1, and the adjacent was root 3. Then for tan pi on 4, if we've got 1 and 1 on each side, the ratio of them is just 1. And then for pi on 3, it's going to be the reciprocal of pi on 6. But at the same time, if you wanted to work through that, you'd find the opposite is root 3 and the adjacent is 1. So tan pi on 3 is equal to root 3. Now, we can also picture these on the unit circle. And all the unit circle is it's just a circle with a radius of 1. Which means that one revolution of this unit circle is equal to 2 pi radians, okay? When we plot on the unit circle, sine of theta is the y-coordinate, okay? So if I wanted to mark 45 degrees, which is here, 45 degrees is equal to pi on 4 radians, okay? Which we said before, sine of pi on 4 is 1 over root 2. Oh, sorry, I've put that in the wrong spot. It's the y value. So 1 over root 2 being the y value. And then for cosine, it's also 1 over root 2. So cosine is your x-coordinate, all right? And sine is your y-coordinate. Now, this just means that your tan value is the gradient between the origin and the coordinate pair that you've got, okay? So in this case, we can see this would be the line y equals x, which means that our tan, which is equal to our m, is 1. Okay, so tan is just the gradient. Now, on the unit circle, we have some very special values. along the way. So just like how we looked at pi on 3, pi on 4, and pi on 6, we've also got things like 0 and 1. Oh, sorry, 0 on pi and pi on 2 and 3 pi on 2, so on and so on. Now, on the unit circle, we always start at 0 and then we work anti-clockwise. So if we go anti-clockwise from 0 and we go here, this is halfway between 0 and pi because it's a quarter of the way around the circle. So that means here we've got pi on 2 radians. Here we've got pi. Here we've got 3 pi on 2. And then this will become 2 pi and so on, so on. So because we're working with circular functions, we can keep going around the unit circle. So if we went here, we would end up at 3 pi. Up here would have been 5 pi on 2. So if you're ever working with something like 7 pi, you can see that you would end up on the left side of the y-axis, all right? Now, that also means that we've got some exact values to remember here. They're a bit easier to picture than the other ones. So going through this table, and keep your unit circle in mind as well. If we've got the sine of 0, that's going to be the y value when we're at 0 radians. Just like cosine is going to be the x value and tan is going to be the gradient from the origin. So the y value at sine 0 is just 0 because we haven't left the x-axis. That means the x value is going to be 1 because with our unit circle we're working with a radian of 1. And then our tan is also going to be 0 because we've got a horizontal line. Now for sine pi on 2, that's that quarter way around, we can see that our y value would be 1, our x value would be 0, and our gradient would actually be undefined. And if you needed to check that, you'd see it would be 1 over 0, which is undefined, okay? Sine pi is going to be 0. Cosine pi is going to be -1 because we've gone over to the left. And then tan of pi is also going to be 0. Sine 3 pi on 2, because we've gone down, is -1. Cosine is 0. And then tan 3 pi on 2 is also going to be undefined because our cosine is 0. Now, lucky last, sine 2 pi is going to be the same as our pi values. So it's going to end up being 0, 1, and 0 because we made it back around the unit circle.